We are going to see about serial port communication. Serial port communication of 8051. It is an 8051 is has an universal occurrence as asynchronous or receiver transmitter, that is said to be your UART. So this is said to be your serial port communication. This is widely used for your serial port communication. The main features of 8051 is it performs full duplex operation, and it receives buffered and access using a single double buffered register, that is SBUF, and it has 4 different modes of operation. And your full duplex serial port means it can transmit and receive data simultaneously. It is also receive buffered, meaning it can commence reception of the second byte before a previous received byte has been read from the SBUF. However, if the first byte still has not been read by the time reception of the second byte is complete, one of the byte will be lost. So 8051 serial port, here the data is to be transferred returned to the register SBUF, and the data received by serial port are read from the register of SBUF. So this technique of having a same address of 2 different register, that is said to be your double buffering. So here your serial port control SFRs. So there are 2 registers of 8051. One is your SCON and another one is your SBUF. That is your serial port control register, which belongs to the address location of 98H, and next one is your serial port buffer registers, which belongs to 99H. And next, in addition to this register, it also has PCON and SMOD. So if your SMOD is set 1, then the baud rate is doubled. So the individual bit of SCON have a function that is shown as the table. Okay, the SCON register has many individual status bits, and whereas this table indicates your bit pattern of SCON. So your SM0 is something that serial port mode select bits, and SM2 is microprocessor communication enable bit, and RE is something that receiver enable, and TB8 is transmit bit 8, and RB8 is receive bit 8, and T1 is your transmit interrupt, and RI is your received interrupt. This from the location of D0 to D0. So your D7 and D6 bits of the SCON register define the operating modes of serial port. Whereas your SM0 and SM1 bits can select any one of the 4 operating modes. Okay. Next, this is your definition of bits of SM0 and SM1 in SCON SFR. Next, a bit pattern description. The next bit is SM2 is a flag register used for enabling microprocessor communication in mode 2 and 3. If SM2 is set to 1 in mode 2 and 3, and the receive interrupt R1 RI flag will not be activated if the receive 9th data bit is 0. If SM2 is set in mode 1, then the receive interrupt of RI flag will not be active, valid bit is not received. Next is your REN. REN is something that receiver enable. This bit is set in order to receive the characters from receiving data line of the serial port. And next is your the TI means transmit interrupt. When the program writes the data into a serial port buffer, then the serial port will start shifting this data in a serial transmit line. And next is your RI is something that received interrupt, where data is received on a received data line of the serial port. This serial data will be shifted into the buffer, then stored in SBUF. So operating modes, this is that bits SM0 and SM1 are used to set a serial mode to value between 0 and 3. So selecting the serial mode selects the mode of operation, and also it determines how the baud rate will be calculated. So this is the block diagram of serial port of 8051. So where it has SBUF internal databases and transmitting clock and transmission and receiver, and also has a receiver clock, and it has a D shift register, and SBUF is physically 2 register with same address, and it also has TXT lines. So next is your reception and transmission. So mode 0, in this mode the serial data is entering and exiting through RXD pins. So in mode 0 the full duplex is not possible, meaning that both transmission and reception cannot take place simultaneously. So here the reception is started by enabling REN in SCON register. So here the signal transmission and reception pattern. This is the figure represent the transmission pattern and reception pattern. This is a clock cycle. Based on this, data has been transmitted from D0 to D7. So in mode 1, in this mode the 10 bits are transmitted through transmission, and simultaneously 10 bits are received through reception. So the 10 bits are made up of start bit 0 and 8 bit of data, that is LSB first, and a stop bit of 1 bit. Okay. Similarly, here baud rate that is equal to timer 1 overflow rate divided by 16 if S mod bit is peak on SFR is set to 1, and baud rate is timer 1 overflow rate slash 32 if S mod bit is peak on SFR is set to 0. So in order to generate the baud rate clock from timer 1, the timer 1 can be configured to act as a timer in auto reload mode. Whereas in your mode 2, in this mode 11 bits has been transmitted through TXT and received through RXT. So the 11 bits are made of one start bit, that is always 0, and 8 data bits, and wherever 9th one is a programmable, it may be a stop bit. Okay. So in your mode 3 the 11 bits are transmitted through transmission, and simultaneously 11 bits is received through reception. So 11 bit is made up of one start bit and 8 bit of data, and a programmable 9th bit, that may be your stop bit. Okay. So in all 4 modes the transmission is initiated by any instruction that uses a S buffer as a designation register. Okay. And this is a flowchart for programming a serial port. So here I have to write peak on, then you have to initialize a timer for mode 1 and mode 3, and you have to write 9th bit to be transmitted in the mode 2 and 3, then is write SCON, do transmit and receive operation. So initializing here serial port, once the serial port mode has been selected, then the programmer must configure the serial port baud rate. And next is in mode 1 and 3, the baud rate is determined by how frequency timer 1 is overflow. The most common method is to put timer 1 in 8-bit auto reload. So this is commonly used baud rates in 8051. So the following set of instruction will set the timer for baud rate of 9600. So here this is a program where move tmod comma the values, that is 8-bit timer, then move th1 the value. Here the timer and counter 1 is timed, then it is set bstr1. Here the timer and counter 1 is enabled for run free. So next is your transmitting and receiving data using a serial port. Once a serial port has been properly configured, the serial port is ready to be used for sending and receiving a data. So whereas in your 8051 that does not have serial output buffer, a character cannot be returned by with SBUF before previous written character. And if you have any clarification related to this timer, please feel free to contact me. Thank you.